My name is Doug Hood, and today I'm going to be talking about the zero latency cache service for Oracle Cloud. We're going to be talking about the cloud latency challenge, what is the zero latency cache, the zero latency cache service, and how to configure at both the cache and cache service and table level. So for any cloud, there's always an inherent problem of latency. What I mean by that is distance matters. The longer the distance, the slower the performance. So the rest of this talk is going to be describing exactly what that means and what you can do about it and how you can solve it with the zero latency cloud cache service. So here we've got a picture of Oracle Cloud regions. So a region is a fancy word for a city which has one or more cloud data centers within it. So as of today, Oracle Cloud has 40 regions, Amazon Web Service has got 27, and currently Microsoft Azure has got the most with 46 regions. So what that means for Oracle Cloud is there's basically 40 cities spread around the world where we have one or more data centers. That's all good. What we're looking at here is where people actually live in the world. So each one of those green dots represents a town or a city. So what you'll notice is in Alaska, northern Canada, Greenland, and Siberia, where it's really cold, there's not that many people living. Likewise, where it's really hot in the Sahara Desert or in the various deserts in Australia, there's not that many people. So the green dots is showing where people live. So the big difference is there's currently about 40 data centers for Oracle Cloud today, and each one of those dots is where people actually lives. So the point I'm trying to make is there's far more cities than there are data centers. So even if Oracle or Amazon or Azure has 10 or 100 times more data centers, there's always going to be more there's always going to be more places where people live in cities than where data centers are. So why am I saying this? It's because it's all about distance. If your system is in the same city as your cloud region, that's good. But almost always that's not going to be the case. Why does that matter? It's all about performance. So if you have a hybrid cloud configuration, and what I mean by that is some of your resources are in your data center and some of your resources are in the cloud, the fact that it's highly likely that your data center will not be in the same city as the closest cloud data center is going to have an impact on performance. So in this case, some of your Oracle databases are in your local data center and some of your applications are in the cloud. So what we're really talking about here is scenarios where you have remote data centers. So let's drill down on that a bit more. What we're talking about here is distance matters for remote data centers. This is really about physics. The round trip time to send messages between one point and another and back again is directly proportional to the distance between them. It's physics. The longer the distance, the longer it's going to take. And you can't just solve that problem by putting in a faster network, because a faster network is not really about speed, it's about bandwidth. The time to move messages between points is going to be limited by the speed of light. It's pretty fast, but as the distances increase, it takes time. So with any application, you're sending data over the network. That data is the network messages. You need to send it, do some processing, and get the answer back. So all of those round trips, all those extra hops takes time. the further apart the different endpoints are, the longer it's going to take. So I talk about the distance tax for the overhead of sending those messages over the wire between cities. Why does this matter? The further the source and the destination are apart, the longer it's going to take. So we can dumb that down to long distances kill performance. So that's obviously a bad thing. How can we minimize this distance tax? So I'm talking about using a thing called the zero latency cache to speed things up. If you can cache your data from your Oracle databases locally within the cloud, that's going to be a lot faster than having to do long round-trip times between cities. Specifically, if you have a really fast local SQL data cache, that's going to really improve performance. So when I say fast, I'm talking about the round trips between your applications and the cache being measured in a few microseconds. If we compare that to the round trip time between cities, that's normally measured in the tens of milliseconds. So what I'm saying is, if you have a local cache which is fast, you can have messaging times in microseconds versus tens of milliseconds. So the point is, if you have a local SQL data cache, things are going to go a whole lot faster than if you have to go over the network between cities. It's just physics. Now, what I've been talking about was scenarios where you had a hybrid cloud, where some of your resources were in your data center and some of your resources were in the cloud. But this issue that I'm talking about, where distance matters, is really independent of the cloud. It's true whether you've got everything on premises between data centers, and it's also true if all of your resources are in the cloud. So what I'm saying is, it doesn't really matter what the configuration is. What matters is the distance between your application and your data. So obviously, the closer your applications are to the data, the faster your applications are going to go. And the further they are apart, the slower they're going to go. Seems pretty obvious, but for various reasons, that's not always the case. So ask yourself some questions. Are your applications in the same region as your database? Which is the same as saying, are your applications in the same city as your database? Because that may not always be true. Likewise, are your applications in the same availability domain as your database? Which is the same as saying, are your applications in the same data center as your database? And finally, are your applications on the same machine as your database? So in all these cases, we're getting closer and closer for your data, applications to the data. So the point being, you'll all probably have different answers to these questions, and they will directly affect your performance. So these are high-level concepts. Let's drill down into what it means in practice. So what I'm saying is, there's going to be different cases. The best possible case is if your cache, your SQL data cache, is co-located on the same machines as your applications, you're going to minimize that round-trip time. If there's no network hop, you're not paying any distance tax. So that's the best case. You can't always achieve that. You may need to have one or more network hops. But what you want to do is try and minimize those number of network hops. Now, if you have a good cache, that means that multiple applications, application servers, and users can all share that same cache. So what I've been talking about so far is a concept called a zero latency cache. What do I mean by that? What I'm really talking about is a really fast SQL data cache. So what is a SQL data cache? I'm going to start by saying what it's not. A SQL data cache is not a result set cache. So a lot of people use result set caches because they're easy to understand and they're easy to build, but in practice, they're not actually that useful. Most result set caches either use key value databases or document databases where you store a SQL query and the corresponding result set. So that works for very limited cases, but not in the more general case. What I'm talking about with a SQL data cache is where you have the same tables, same table names, the same column names, the same data types, and the same data between your Oracle database and your cache. So if you've got the same tables and the same data, you don't have to completely rewrite your application like you need to do with a result set cache. You're minimizing the amount of things that you need to change for your application to talk to either the cache or your existing Oracle database. So more specifically, if your SQL data cache is based on a SQL database, that means we're using SQL tables with familiar things like primary keys and foreign keys for your read-write caching. That means you can use the same SQL and PL/SQL in either your cache or your Oracle database. So if we make it all very similar, we're minimizing the cost of your application changes to use a cache versus your Oracle database. Now, the specific technology that I'm talking about here is an in-memory database called Oracle TimesTen in-memory database. And we're going to be using that as a cache. So when I say this cache can use SQL, it turns out it can use the same SQL as an Oracle database. Now here's two examples of that. This is using the old school Oracle syntax and the newer ANSI SQL syntax. We support both. So in this first example, we're doing a join between two tables, and we're using the Oracle syntax for an outer join. So we can support that with TimesTen. We can also support the ANSI SQL syntax where we're explicitly specifying the join type. So with TimesTen SQL, you can either use the Oracle syntax or the ANSI syntax. Both will work. With TimesTen SQL, you can do trivial things like this, but you can also do more complicated things like using cubes, roll-ups, grouping sets. You can even use common table expressions via the SQL with statement. So the point is, you can do pretty powerful SQL statements, be it transactional or analytics, if you use the Oracle TimesTen in-memory database for your cache. So you've got good SQL coverage. But how is your application going to use that SQL or PL/SQL? It turns out you can use the same SQL APIs and SQL drivers in TimesTen as you do with the Oracle database. What do I mean by that? What I'm saying is you can either use the existing Oracle SQL APIs or drivers for Oracle. You're choosing your favorite language API. So whether you're using newer languages like Python or Node.js, or old school APIs like ProC or ProCobol, those exact same SQL drivers that you use for the Oracle database, you can also use with TimesTen. So whether you're using the Oracle drivers or equivalent open source drivers, both will work. So if you've got open source drivers for an Oracle database for languages like Go, Rust, any one of these, they will also work with TimesTen. So what I'm saying is you can use the same SQL and PL/SQL and SQL API drivers that you would use for your Oracle database also in TimesTen. So if you've got the same data model, the same SQL, and the same drivers, you're really minimizing the amount of changes that you need to make to use a cache. So we're trying to make it as easy as possible for developers to use the TimesTen cache. Now, I've talked a lot about making your applications as close to your data as possible. That's a given. The other thing you want to do is you want to have your cache be significantly faster than your Oracle database. Because if the cache isn't faster than the database, what's the point of using it? So here's some example of the sort of performance that you can get out of the Oracle TimesTen in-memory database. So using Oracle Cloud with AMD EPYC CPU shapes, doing some fairly simple SQL select statements based on primary keys and some updates. We can do the select statement in about 1.7 microseconds and the update at about 3.9 microseconds on average. Now, I really want to emphasize I'm talking about microseconds here, not milliseconds. You measure the performance in Oracle database in milliseconds. For the TimesTen in-memory database, you measure performance in microseconds. So just remember, there's 1,000 microseconds per milliseconds, so it's significant. On average, it's significantly faster to use TimesTen than to use an Oracle database. So I'm talking about really fast here. Now, obviously, these are pretty simple SQL statements. If you're joining 20 tables and returning large results there, it's going to take longer. But the point is, simple operations can be very fast, and complicated operations also tend to be quite fast. How long they take depends. The point is, it tends to be a lot faster. Now, I just want to emphasize Oracle TimesTen is a SQL relational database. As such, it has tables with columns, with types, with constraints, with schemas, primary keys, foreign keys. So it's very familiar to an Oracle database because it's a SQL relational database and it's using Oracle types like varchar and clops. So same data type, very similar syntax. Likewise, another screenshot from SQL Developer, you've got a table with columns and data. It's the same user experience. So I've talked about a challenge of any cloud, which is latency, which is related to distance. I've talked about how using a cache can dramatically speed things up. But the question becomes, how can you configure this zero latency cache in the Oracle Cloud? The answer is just about configuring metadata. So let's have look at some examples of that. So the TimesTen Zero Latency Cache Service will show up on your Oracle console just like any other service. The look and feel should be very familiar. So you're collecting metadata about the system. So you've got to collect things like the name of the cache service, and more importantly, where it's living, where it's going to run. So you're specifying the Oracle Cloud region, and within the region, you're specifying which availability domains or data centers it's going to run on. And you can even specify it down to default domains within that availability domain. So you're not only specifying the city, the data center, you're also really specifying the racks which this will run on. So the more accurately you can specify where things run, if you can make that the same or as close as possible to where your applications are, you're going to minimize the round trip time to maximize the performance. So you're also going to be specifying what sort of resources it's going to be running on, whether it be bare metal, VMs, so you're specifying the compute shapes. You're also giving information about the system, so the credentials for the TimesTen database and various attributes, how big the database is, what your database character set is, and the like. Because you're caching from an Oracle database, you also need to get information about that Oracle database. So you're getting things like the credentials for the Oracle database and the various SQLnet configurations which you're going to be talking to. Likewise, because it's on the cloud, security matters, you need to be configuring all your security. So what we covered there was some fairly simple screens where you're collecting metadata about what you're configuring and where it's going to be running. So that was configuration at the cache service level. Now I want to look at some configuration at the table level, because you're going to be caching specific tables and specific schemas in Oracle databases. So there's a couple of ways you can do that. I'm showing you the simplest. You can use Oracle SQL Developer, a wizard in that, to create, to specify the metadata of interest. So you can just click through this wizard to collect the information you need, and then it's going to generate the information you need. So in this case, we're creating things called a cache group. What's a cache group? It's a set of related tables that you want to cache. So a cache group can have one or more tables. It can be in hierarchies. So you can create one or more of these cache groups to specify the various different tables and schemas that you want to cache. So you're also specifying behaviors. In this case, this cache group, is it going to be read-only? Is it going to be read-write? How are we going to do the writes? So the point is, you're specifying what you want so it can figure out how to do it for you. So in here, we're going to be specifying the specific tables and the schemas. So we're pointing to a table. In this case, we've got the employees tables and the departments tables, and there's a one-to-many relationship between those tables. So we're just pointing to objects. We're using the Oracle database data dictionary to look up these objects to specify what we're after, and we can point out things like what the foreign keys are, what the corresponding primary keys will be. We can choose things like indexes. So we're specifying what we want so we can figure out how to make it work and go fast. Once we've got all the information, we can check to verify it's all correct, and then we can generate the information that we need to use at runtime to do this caching. So on the left here is a screenshot. It's a pretty simple example. We're using the departments table with the columns of interests and the data types and their constraints and the schema that it's going to run in. So that looks like a table definition. It's really a cache group definition. So we're specifying we want to cache that data in a read-only manner, and we want to check for changes every 5 minutes. But 5 minutes is arbitrary. You're choosing on a table-by-table basis how often to check for changes. You may want to check every 10 milliseconds or even continuously for changes. It really depends on the specific table, how often that table's changed, and the business need. So you're saying what you want, you're specifying when you're generating this information, which will, at runtime, TimesTen will do the right thing to automatically do that caching for you. So this is a very simple example with a single table. Here's a more complicated example with 2 tables, and it's got some more columns. But the point is you've got tables, employees, HR schema, columns, primary keys, foreign keys, and we just got a list of these. In this case, we also specified the department table. So the point is you can specify thousands of tables that you want to cache. So you always have the choice of which tables and which schemas to cache. You're choosing which columns and which rows. So you, as the user, are defining what you want cached, and we will then generate this information to automatically do it at runtime. Now, once you've created this cache group, how is your application going to use this cache? Like, you know how your application uses the Oracle database? You're specifying metadata to connect. You're normally specifying the username and the password and some way of connecting to that database, usually via a SQLnet service name. So you know how to do that for an Oracle database. Guess what? You do it the same way for TimesTen. You're specifying the same username and password. You're pointing to a different service name, which is pointing to the TimesTen database rather than the Oracle database. So it's the same concept. So whether you're using TNS names or LDAP, it's going to depend on the specific API for the syntax. If you're using JDBC, you'll be using JDBC URLs. So the syntax, it's going to be dependent on the APIs, but fundamentally you're just pointing to a different service for TimesTen versus the Oracle database. So ideally, if you've got the same schemas with the same tables, with the same columns, with the same data types, and the only thing that you're specifying is a different connect string, it's making it pretty simple to use the TimesTen cache for fast access to your data rather than an Oracle database. So that's the best case. So I've talked about the challenge of distance and how it affects performance. I've talked about how using a local cache can make things really speeded up. I've talked about how TimesTen can be that cache and how the zero latency cache can make that simple for you. So this is all sounding good. So the Oracle Zero Latency Cache Service is due out next year, so we plan to release it in 2023. So that's the end of the talk. We've talked about using the zero latency cache. Here's some more resources to give you more information about Oracle TimesTen in-memory database and caching, whether you're using TimesTen, which is a licensed product which is supported, or the free version of TimesTen called TimesTen XE, which is not supported. So you have choices. Thank you, and that's the end of the talk.